All right, so we're starting Unit 4, and Unit 4 is on contextual um, applications of the derivative. And I'm not sure how much of this summer day of calculus you guys did on your own, but I do want to go over it with you all because there are some super important connections made here. So anyway, so this is Miss Skipper's perfect summer day. Is going to start and end with calculus. From the amount of coffee in her morning cup of joe to the lines at an amusement park to the temperatures of her marshmallows. There's never a shortage of derivatives. So we're going to explore some of the rates of change that occur around us. So for number one, the hot water dripping through a coffee maker filling the skipper's mug with coffee. The amount of coffee in the cup in ounces is modeled by that function b of t, where t is time in minutes. So we are going to find b prime of t, and that derivative is not hard to find, but to actually find it, to estimate it, we have to use a calculator because we can't do e to the power in our head. So we're just going to go ahead and use the calculator on this. Because if you have to find b prime of t and you can use a calculator, I recommend that you just go ahead and use one. All right, so you may have to use, if you're at home, you may have to use Desmos, or hopefully you have your own calculator. You can find some kind of source. But on the TI-84, we're going to go to y equals, and we're going to type in the function. Oops, let me start over. That was typing in the derivative I had written down already. I'm going to go ahead and use x since we're in function notation. Okay, so then I will quit out of there. And then to find the derivative, we're going to use alpha window number 3. And again, I'm just going to go ahead and use x. And then since I put that in y1, I'm going to use the alpha trace buttons and choose y1. And we're evaluating this derivative when x is 5. Right, there it is. Okay, so b prime of 5 is, and we want to be accurate to at least 3 decimal places, so round or truncate. Okay, and so B asks, what are the units of b prime of 5, and how do you know that? So there are some important things that I need you all to always remember about the derivative, and one of those is to remember the derivative is a rate of change. All right. And then also don't forget the Leibniz way of writing a derivative. So this is going to be dB over dt, or dB dt, which dB should represent the change in coffee, and dt the change in time. All right, and so in this case, coffee is measured in ounces, and time is measured in minutes. So this is going to be ounces per minute. Okay, and then one major thing we're doing today is interpreting the meaning of these derivatives that we're finding. And so I'm going to write it out, and then on the back we'll write like a generic statement that you do whenever you're interpreting these meanings. So don't forget that the derivative is the instantaneous rate of change. So it is just at a single moment. So the moment is when the minutes is 5, so at 5 minutes. All right. right? And then the thing that is changing is the amount of coffee in the mug. So the amount of coffee is, and then since this rate is a positive value, the amount of coffee is increasing at a rate of 0.866 ounces per minute. Right. And like I said, we're going to practice that on almost every single problem we do today. All right, so this is a little out of order. So at the end of the day, I'm roasting marshmallows and over the fire, and the table gives the selected values of the temperature in degrees Celsius of a metal stick that is heated from the end. So X is the number of centimeters from the end of the stick. All right, so we're going to estimate T prime of 4. But because we have a table, we can't find it like we did on number 1. We had an equation. So the way that you estimate a derivative is to use an average, using a table is to use the average rate of change. So we're going to use the average rate of change to estimate the derivative. I originally wrote to estimate the instantaneous rate of change, which you could write that also. Right now, there are multiple average rates of change that we can find to estimate T prime of 4. I'm going to use the two that are right around it. But as long as X is 4 is in between or one of the values that we're using, it is an estimation. So T prime of 4 is going to be approximately, because this is an estimation, T of 5 minus T of 1 over 5 minus 1. All right, and then we can just get these values from the table. All right, so we end up with negative 23 over 4, or using the calculator, it's negative 5.75. And let's go ahead, it doesn't tell us to, but it does, we're going to go ahead and use the units. So this is how fast the temperature is changing. So the change in temperature over the change in time. Oh no, change in distance. Sorry, distance is in centimeters. Okay. And then it asks us, what does the value of T prime of 4 mean in the context of this problem? So we're going to say at, and then remember this is a specific moment. That moment is when X is 4 centimeters, or the distance is 4 centimeters from the end of the stick. The temperature and this time the rate of change is negative, so this temperature should be decreasing at a rate of 5.75 degrees Celsius per centimeter. All right. And I do also like amusement parks. So at Cedar Point, Miss Skipper notices all the people coming and going. The rate at which people enter the amusement park is represented by EFT. and the rate at which people leave the amusement park on the same day is represented by L of t. Both E of t and L of t are measured in people per hour. So this is kind of different because it is a function that's represented just E of t, but it is a rate. So that gives us the rate. Each one of those is a rate. And they do that sometimes. So we're going to let H of t be equal to E of t minus L of t. And we're going to find H of 17. And that's just going to be E of 17 minus L of 17. And that can just be found in the calculator. So I'll just jot down what you get when you put 17 into E and when you put 17 into L. All right, that's going to give us negative 380.281. All right, then we have to interpret what the meaning of H of 17 is in the context of this problem. So we didn't really talk about what H of t is. We talked about E and L. And if we take the number or the rate at which people are entering and subtract the rate at which people are leaving, that should be the rate of the total number of people in the park. All right. And then remember, this is a specific time. So it's when t is 17. So don't forget that t is the number of hours since midnight. So 17 hours since midnight is going to be 5 p.m. All right, and the H of t is going to be we're going to say the rate. No, we're going to say the number of people in the park, not entering and not exiting, just the total number of people in the park is, since it's negative, going to be decreasing at a rate of 380.281 people per hour. All right, so this one was a little different. The other two, we started off with the T of X was the temperature, and V of T was the amount of coffee. This one started off, H of T is a rate at which people are in the rate at which people are the rate at which the number of people is changing in the park. So it's a little different when we do our wording. So for C, this is just talking about E. So what would the units be of E prime of T? So that's going to be basically d E dt. All right. And then E is measured in people per hour. And time is measured in hours. So it's going to be people per hour per hour. Okay, so let's move here to the notes section. So our important ideas is that the derivative represents the rate of change of the dependent variable with respect to the independent variable. Okay. And then our units for, I'm going to put f prime of x is going to be the units of f divided by the units of x. So every time you do a derivative, you're taking the dependent variables units and dividing them by the independent variables units, right? So then if we want to find the units of the second derivative of f of x, is going to be the units of f prime of x divided by the units of x. All right, and then for interpreting it, so what we would say is at x equals blank, and it might be t equals blank. It just depends on the context of the problem. The blank is increasing or decreasing, so you have to determine that yourself. At a rate of blank, and then you want to use the correct units. All right, and then I'm just going to use a different color right here. So this blank is going to be the y context. All right, so let's look at Alvaro. So Alvaro is studying the extinction of the bear population of Siberia over time. The following function gives the number of bears t years since Alvaro started tracking it. And again, this is not a hard one to find the derivatives using the chain rule, but to be able to find this value, we would have to use a calculator anyway. So let's just go ahead and use the calculator. Okay, so let's go to y equals, and then we are going to type it in. Okay. And then I could retype this, but I'm just going to pull it up because I'm trying to get this done. And then we want to type 3 in for x. Oh, no, sorry. There we go. All right, so that is b prime of 3 is going to be negative 267.116. And let's go ahead and use the units. So don't forget that is the independent variable units divided, I said that backwards, sorry, the dependent variable units divided by the independent. So the function gives the number of bears. That's going to be the dependent. And then t years, that's going to be the independent. So the dependent is the number of bears. So this is the bears per year. All right, and then we want to interpret this in the context of the problem. So that's this kind of generic thing we wrote. So remember, this is at a certain moment in time, and that moment is 3 years. So at t equals 3 years, and then the context of the problem, the context of this problem is the bear population. So we're going to say the bear population and then we have to decide if it's increasing or decreasing. So it's going to be decreasing. Sorry, I'm struggling writing words. At a rate of 267.116 bears per year. Now, when you say decreasing, don't write negative. If you want to write negative, you could say changing. But we would say decreasing takes care of the negative, and then you just use the absolute value of the number. Okay, the next problem is on wind chill. So the wind chill in degrees Fahrenheit that a human feels is dependent on the air temperature in degrees Fahrenheit, as well as the wind velocity in miles per hour. So at a temperature of 32 degrees Fahrenheit, the wind chill is given by that function. And this is only valid for velocities between 5 and 60 miles per hour. So again, we can just use the calculator to find it. So I've already done this, so I'm just going to have you guys trust me that I typed that function in Y1, and then I used alpha window to find the derivative in the calculator at x equals 20, technically v equals 20. All right, so I got that. And then it's degrees Fahrenheit per miles per hour because the wind velocity is given in degrees Fahrenheit. The wind chill is given in degrees Fahrenheit and divided by the independent variable, which is in miles per hour. All right, so then for B, we're going to interpret the meaning in the context of the problem. So our moment is 20, and that moment is a velocity, which is 20 miles per hour. And this problem, the context of this problem is wind chill. All right, because the rate of change is negative, we're going to say this wind chill is decreasing. At a rate of 0.286 degrees Fahrenheit per mile per hour. But sometimes doing these units is more difficult and it's kind of harder to understand wind chill unless you have some experience with it. All right, and this last one is about Joanna. Joanna is running along a straight path for 40 minutes. Her velocity is given by a differentiable function, v of t, where v is in meters and t is in minutes. Selected values of v of t are given in the table. So all of the things we get out of this function are meters per minute. What we put in is minutes. All right, so this is one where we don't have a function in an equation form or algebraic form. We have a table. So don't forget that when you're estimating a derivative or an instantaneous rate of change using a table, you use an average rate of change. And since this is an estimation, it would be best if we do a little estimation equal sign. All right, and then like before, we talked about on the front with the marshmallows, there are multiple ones we can write. I usually will use the points that are closest to what we're estimating. So this is going to be v of 20 minus v of 12, and that's going to be over 20 minus 12. All right, so I'm just using the table. All right, that is going to end up being 5. And then let's talk about the units. So we're going to take the units of the dependent variable, meters per minute, and divide that by the units of the independent variable, which is minutes. So this is going to be meters per minute, which is an acceleration. All right, and then finally, we are going to talk about the context. Why don't you try the context on your own? Pause it, see if you can do it on your own, and then check with mine. Okay, so your assignment is to complete the worksheet that I also attached.